I don't have anything to screen record with, so I'm just going to be doing it on the whiteboard. I hope this is a good enough clarity. Here's my diagram. I just kind of drew out the triangles to help me visualize the direction of everything and how to kind of reorganize some of the angles so that I can use them how I want in this equation. But everything still works the exact same. And then my basis here is going to be x positive this way, y positive this way. Yeah, that's that for the diagram. Now we move on to the math. The main math here, I'm just going to start with trying to find the cosine of this 15. Because if we kind of break this up here, the cosine of the 15 down here, this is going to be our x. So 30 meters per second, that's our x, and then our y for a is 0 because it doesn't go up any. So then I'm going to find the cosine for this 15 meters per second for b, so that we can find our velocity in the x for b. Alright, so there is our velocity in the x direction. There's no, the circle doesn't really have an effect on this just because this is an instantaneous velocity. There's no time, there's no, acceleration doesn't really have an effect on the velocity at this point. So this is just the instantaneous velocity right here. So there's nothing affecting it. So now we can kind of break this into the I hat and j hat. And I did do the sign, but I did it on my paper, but that is equal to 7.5. So these are our two, sorry, my handwriting is a little messy. I get that, I'm sorry. But these are our two velocities broken up into the x's and y's, and then we're going to find the sum of these velocities. Or no, sorry. We're going to take the relative velocity of the x and the y, and then we're going to turn it into the magnitude. So we can find the general speed. It won't have a direction, but it will have a value. It will have the overall value. So let's do that here. So this is our relative velocity with respect to a, relative velocity of x, relative velocity in the y. So now all we have to do is find the magnitude of this. So that's just going to be the a squared plus b squared equals c squared. And then if we solve that, we have the relative velocity of a to b. I don't really know how to write like the relative velocity of a, but I'm just going to do a, b is equal to 18.59. So that is our meters per second. Let's make sure, not squared. 18.59 meters per second. So now moving on to the acceleration part, as I realize that I have drawn in a diagonal. My bad. I will section this off though, so that it's a little easier to understand my chicken scratch that I call writing. So what I did was I had to calculate centripetal acceleration, not centrifugal, centripetal acceleration. And then that would just end up being n is equal to, and then this top part would be, since our v squared is just going to be the 15 here, and we have this, we have our radius, which is 100 meters, so we can just do 15 squared over 100, which is equal to 2.25. There we have it. So then I kind of just broke this whole top part into two different triangles. So I have the centripetal acceleration kind of as one problem, and then I have the other just regular acceleration as another. So that way we can bring them together and then get our total acceleration for this whole thing up here. And then we can combine it with this one down here, or find the relative acceleration with this one down here. All right, so this is just the triangle we're working with. This is just straight from here, the centripetal acceleration. And I did do the work for this on my paper. I'm not gonna try and like calculate it out here. But yeah, it's just some basic geometry to kind of fill out the rest of the sides here. Okay, so those are our accelerations in the X and Y direction. So this is positive. That's important because the centrifugal acceleration is pulling it this way, and it's also pulling it up. So those are both positive. But now for the one over here, we're kind of looking at this kind of triangle. So this is going to be negative, this one's going to be positive, and this is our 2 meters per second. You can just do some math to figure that out. And yeah, it just kind of boils down to that. We have 2 here, 1 here, and then a kind of gross decimal, but we just plug that into a calculator when we have to make our final equations. So that's no issue for us. So here's everything written out. These two are kind of together, and then these two are kind of together. So we have these two, which are going to be these two accelerations in vector or in XY form, kind of laid out here, and then I combined them together to get the resultant kind of speeds from those, or the resultant acceleration. And then I took the A here, which we know is just -3, and it's not going any, there's no acceleration in the Y direction, so that's just going to remain 0. And yeah, then we just take the find relative acceleration for that for each of the X's and Y's. That's going to be a, so that's what we have there. Boom, that's our resultant. And then we are just going to find the magnitude for this. So that is our final answer for this one. And this will be, so this is A here, and this is B. So this is our final acceleration, and this is our velocity there. So that is all. Thank you. I hope this was good enough. If there's anything that I did wrong, I would love to know. I'm sure I made some mistakes here and there, but yeah, if there's anything you can improve upon, please let me know. Thank you.